Okay, today we are continuing with that theoretical probability, and now we're learning about experimental probability. So yesterday we learned that theoretical probability is what should happen. Today's experimental probability is what actually happened. So our work from yesterday, we're going to use that data for today. So you were to write down what your heads and tails actually were. We know the theoretical was 25 heads and 25 tails. So if we look at our theoretical, hello? He is here. I will send him down. Thanks. Ryan, go get your device. Okay, so if we look at the theoretical heads and tails, remember we have 31 people in our class. So how many heads and tails should we get? Who remembers from yesterday? You can look at yesterday's numbers. Garrison?
1,550, right?
So altogether it would be 1,550. So how many heads would that be?
It would be 775 heads and 775 tails.
It was 775 heads, 775 tails. So we're going to see what our actual is for the class. So I need somebody with a calculator. I'm going to go with Ethan. Okay, so Ethan, get ready, and every number that people say, you're just going to keep adding it on. Okay, so let's start with your number, Ethan. We're doing heads first. So you're going to say what your actual head is, and Ethan's going to add it together. And if somebody wants to be a backup, you can be a backup, but everybody can be backups if you want to, but I'm going to go to Ethan to be the official one to tell me. Okay, so we need to be silent so we can all hear. We're going to go around the tables of what heads you got. So Ethan, what heads did you get? Say it nice and loud so everyone can hear.
24.
Okay, so start with 24. Garrison?
I got 21.
Ashley?
19.
Jocelyn?
40.
Gavin?
25.
Owen?
25.
Finn?
28.
Naveen?
25.
Paisley?
29.
Maddie?
19.
Molly?
25.
Andrea?
24.
Chase, did you get your heads done yet?
I did.
How many heads did you get?
28.
Izzy?
22.
Charlotte?
21.
Julian?
23.
That was a 23 if you didn't hear. Nathan?
20.
Amelia?
24.
Sam?
30.
Caitlin?
22.
Paul?
I got 26, but I did it.
No, I don't want tables. Sam?
23.
Joseph?
25.
Ryan?
25.
Naomi?
25.
Katie?
28.
Leah? Colin? Briggs?
22.
Cole?
25.
Edward?
8.
How much does that equal? Ethan?
It's maxed out. Yeah, maxed out mine.
Okay, what did you get, Edward? 702. Is that what you got, Briggs? Naveen?
I got 747.
What'd you get, Caitlin?
727.
You got 727 also? Okay, so we're gonna go with the one that we got the most of, plus it's in the middle of what everybody else had. So we're gonna say 727 heads. You got 727 also? Okay, so instead of having to go all the way around to find our tails, what can I do? Colin? Yeah, if we had 1,550 all together, how many tails should we get? Maddie? 823? Okay, so the theoretical results were 775. Compare your results to the class results. Which was closer to the theoretical probability? Yes. Oh, it's okay. It's close enough. So, 727, 823 versus the experiment versus your individual. Which one is closer to the theoretical probability? How can we figure that out? If you got 22 and the theoretical is 25 versus 727 and the theoretical of 775, how can we compare those? Cole? Is that going to be a fair way to compare them? Izzy? Oh, you could find the percentage. How would we, well, so let's say we were one of my friends that got 22 and 28. How can we find the percentage for heads? Izzy? It was out of 50, so we could do 22 out of 50 would be what percent? What is it? 44%. So what would the 28 be? So what is 727 out of 1,550? Maddie?
It's 90.
No, it's not.
90.
It's not 94%. 47%. Because you, Maddie, you have to do 727 divided by 1,550. Briggs, what was it? 47%. And so what would the tails be?
53%.
So what do you think? Which one is closer to the theoretical probability? Remember, theoretical probability, if we did 775 out of 1,550, what percent is that? You have a 50-50 chance, right? So 50% chance. So which one is closer to 50%? The class results are closer to 50% than your individual results. So, yeah. 53 is closer to 50 than 56 is. So let's look at our dice. So I should have wrote on here class results because the class results were closer. So you should have written your individual results from rolling the die 120 times. Now we need the class results from rolling the die 120 times. So that means we actually have to go around for each number. So we're going to go around for the ones. We're going to go around for the twos, go around for the threes, the fours, the fives, and the sixes. Here's what we're going to do to make it go a little bit faster. Do what Paul's table did for the heads and tails and get your total for your table. So we have less numbers to add. So we're going to start with the ones. Get your table amount for the ones. Somebody be the recorder and write down what your table results were.
I got 18. I got 2 4s.
So for Charlotte's table, do the 3, and then when Chase is done, we'll add in his. so for two?
Yeah.
Okay, well now, 78.
I got 25 3. You got how many more? Living, how many more? 27, how many more do you have then? Yeah, I got 2 more.
You only got 2 fours.
Okay. I got 23 5.
I got 25.
What did you get? Five.
It's like times very cool. That is cool, Finn.
Okay, I got 30
Okay.
I got 2.
Is there any tables that are done adding up all their dice?
No, we're not, Maddie.
You've added them all up? Okay, for those that are done adding up, I'm gonna start writing down their numbers. Okay, the rest of you finish adding it up until we can add yours. Are you guys done now?
Yes.
Katie, your group is done? You're done? They're gonna, is Chase done rolling the dice? Okay, so you're gonna add that in. Okay, so I'm gonna write down the 8 numbers, because there are 8 table groups, and then we're going to add them up. So, we're gonna start with Owen's table. You're gonna tell me all 6 numbers, and then we'll go to the next table group, and we'll do those 6 numbers, and then we'll add them up, okay? So, Owen, how many ones?
71,
Twos,
85,
threes,
75,
fours,
76,
fives,
88,
and sixes.
89.
Garrison,
Number 1, 67.
twos,
Number 2, 73.
threes,
71.
fours,
84.
fives,
90.
6.
95.
Sam,
I got 1, 81.
twos,
77.
threes,
79.
fours,
81.
fives,
75.
6.
87.
Sam, M.
I have those.
Okay, Paul,
1, 77.
twos,
72.
sorry, 72.
Yeah.
Threes,
81.
fours,
106.
fives,
95.
6. Kate, 52, 53, twos, 3s, 4s,
71.
5s, and 6s. Andrea,
1 or 74. 78. 67. 83. 100.
the same.
Okay.
59 for twos. 68 for threes. 4 is 93. 5 is 95. And 6 is 77.
So we have one more table we're gonna do. As I'm adding them in, somebody can be adding up the ones. Somebody start adding up the twos, and as we get that last group in, okay, so it's,
I'll get 5. I'm on 6s.
who has the results? Charlotte.
For 1, we got 7. For 2, we got 84.
Guys, you have to stop talking or I can't hear the results. What are the twos?
84. 3, we got 81.
I'm sorry.
81. For 4, we got 84. 5, we got 88. And for 6, we got 68. We got 68.
Who has added up all of the ones now? Maddie? How many twos? Has anybody added up the twos?
You can do it quickly.
Ones are 581.
I have the threes.
What are the threes, Garrison?
I got 580.
Everybody is silent. Garrison, what are the threes?
582.
Andre, what do you have?
690.
690 what? What were the twos, Caitlin?
580. I have the 6s. I have the 4s.
Was that Finn with the fours?
Yeah.
Finn?
I don't know if I did my math wrong, but I think I got 585.
And Paul, what were the sixes?
692.
We should check it and make sure it's right.
Yep.
Yep.
Call and double check mine. Yeah.
Yep.
Just like add them all up and see if they equal.
Go ahead. I don't have my calculator out. You do.
What should we add up?
What was our theoretical was 3,720.
Wait, all of us.
Yeah, the answer is 3,640. I got 41. I got 84.
Okay, so re-add up the fours.
Yeah, it's
678.
What was it? What else did people get for the fours?
678.
Okay, so the fours were our wrong number, 678. Now check our math.
It should equal 3,760.
3,720
Well,
is what we should equal.
yeah, but it's 3,733.
So somebody added a few too many.
But we know the 6s are good because we checked.
So yeah, double check your 1s, 2s, 3s, and 5s.
I checked mine before we even did the 3, and I noticed I had 130, so I just took away a 10 from one of them.
And it could be, friends, it could be somebody made a mistake on their individual count. That also could have happened.
Our table checked 3.
Okay.
I checked ours. This one is, yeah, this is so 5 is good.
So 4, 5, and 6 are good. 2 is good. 2 is good. All right, so check the 1s and the 3s.
That's 88, right?
Yes.
1's good. So is 3 good? Yeah, 3's good as well.
3's good.
So it's an
Okay, so somebody messed up on this, or a few people messed up on the individual count by a little. We're close. Okay, so how many did we have? 3,701?
33.
Okay, so we're gonna go off of that number. Okay, compare your results to the class results, which was closer to the theoretical probability. So if we're going by theoretical probability with the class results, think about what percentages we would be at. So you figure out your individual results, your percentages. I'm gonna figure out the class. You figure out your individual. So the theoretical was what? So let's do 3,733. Because we had the wrong number. So
that would be 17%.
17%? Okay. So our theoretical probability is 17% for each roll. So we had a 16%, a 16%, a 16%, an 18, a 19, and a 17. How did you guys do with your experimental percentages, Andrea?
I got a 15%, 19%, 18%, 10%, 21%, and 17%.
So how close was that to the theoretical? Which one would be closer? Andrea's experimental or the class experimental? The class experimental. Who else can tell me how they did in comparison with the class? Colin?
I got 18%, 12%, 17%, 18%, 17%.
So your last four were fairly similar, but those first two were way off. So our overall class was pretty steady being close to that 17%. We didn't have any outlier ones. So the class is closer than Colin's. One more. Garrison.
Mine was 10%, 16%, 19%, 18%, 16%.
So that 10% and the 21% were pretty far off. Okay, so we had some outliers again. So overall, what do you think? Do you think the class results are closer to theoretical or your individual? Class results. So both for the coin toss and for the dice roll, the class results were closer to the theoretical probability. Let's find out why. The law of large numbers. Which numbers were larger, your individual or the class? The class is a lot larger. So the law of large numbers says the more time you do something, the closer experimental probability gets to the theoretical probability. Whoops. Okay, so if I were to do something 5 times and you were to do it 20 times, who's going to have better results? The one that's higher. If you do it 20 times, you're going to get closer to that theoretical probability. So when you're doing like a science experiment, should you just do the experiment one time? No, you should do multiple trials. Those multiple trials are going to get you closer to a theoretical probability. You're going to get better results, more trustworthy results. Because maybe on this one trial, we have this outlier. Oh, I only got, 2 4s? Owen only had 2 4s when he rolled. That's not what the majority of us had. So it's going to say, ooh, yeah, that one was a goofy trial, okay? And it gets factored out as we have way more trials, the numbers get more accurate. Yes, Andrea. Is it always the case that the more trials you do, the better, the closer you get? Yes. Yes. It's a law. The law of large numbers. The more time you do something, the closer your experimental probability gets to the theoretical probability. The more time. So I'm not just saying this one time you got lucky and you were hitting it on with your heads and tails. You got 25 and 25. Woo, lucky. Okay. We want to get that experimental probability. You want to keep going. You can't just say, ooh, I made it this time. I don't have to do any more. Okay. The more times you do it, the closer you get to that theoretical. I'm not talking about that one lucky time you got 25 and 25. That was luck. Paul.
So you're usually always gonna get class results. Is that what you're saying?
The class results will always be closer to theoretical than your own, unless you had that lucky outlier where you got 25 and 25 with your heads and tails. Okay. Use the spinner below to determine if the result is above, below, or equal to the theoretical probability. So this you're going to work on your own. And you're going to think it through. You take 12 spins and you get 4 twos. So think it through. If you're doing 12 spins, how many times do you think you're going to land on those twos? I want you to go through this on your own, and then we'll talk about it. But I want you to do some of the thinking yourself. Think it through. Are you going to be above, below, or equal to a theoretical probability? So what do you think you want to do? What's your first step, do you think? Izzy? You're going to want to find your theoretical probability. Okay, you can't just make a guess. You have to know what the theoretical probability is and then determine, are you going to be above, below, or equal to it? So for anybody watching this at home, we hope you are well, and we hope to see you soon.